If we replace our body with the machines, we can survive forever.
Some of the best scientists in the world want to make us immortal, and they want to do it by turning us into machines.
Our final goal as a human is to be a robot. Konnichiwa.
Konnichiwa.
Look at that cerebellum right there. Isn't that neat? Frozen in time.
You may be able to download the mind of a person and then play it back.
Yeah, this is some weird science. Now, if you're in the market for an eerily lifelike robot clone of yourself, and who isn't, right? There is probably one person you should talk to. This is Professor Hiroshi Ishiguro, and he's at the cutting edge of making androids as human-like as possible.
Konnichiwa.
こんにちは。はじめまして。私はアンドロイドのエリカです。お名前なんて言うんですか?
Oh, and that's Erica, his most lifelike creation yet.
私の第一印象、聞いてもいいですか?
美人じゃないです。
は?
Yeah, we'll probably just have to skip past the questionable gender dynamics at play here. But the key question here is, how lifelike can we make robots? As technology advances, rather than having a generic Erica, we might start uploading far more personalised traits, our memories, our specific characteristics. And in that sense, could we live on forever as some sort of clone or drone?
Death is to disappear from this world. Of course, our consciousness disappears, but if we have Android, we can improve the Erica-like robot more and more. Then Android will become the person who passed away, and then we may keep that Android as a family member. If I pass away, my Android is living in society forever.
Regardless of whether you think this is something you actually want, or just really creepy, you might be thinking, well, just because this android has my memories and behaves like me, is it actually me? Or is it just an echo of me? So some people are looking at this in a different way. They say for us to really live on forever, it's our entire brain, our very consciousness that needs to live on after our body dies. And they want to do that by mapping our whole brain, all 86 billion neurons of it, and eventually uploading that onto a computer. So you won't need your flimsy human body anymore. But first of all, there's a kind of important hurdle that we need to overcome first. Can we even map the human brain at all? Now, this question is very far from fringe science.
The next great American project, that's what we're calling the Brain Initiative.
This is a huge multi-billion-dollar attempt at solving the mysteries of brain disorders, and a central part of that is to one day map the entire human brain. This means working out how specific neurons in the brain might cause us to perform certain actions. And Professor Raphael Yuste is one of the pioneering scientists tasked with leading this quest.
The idea that you can upload the mind assumes that the mind is some sort of digital computer.
But to answer this massive question, Professor Yuste is starting small, extremely small. A hydra is a tiny freshwater organism that only grows about 10 millimeters.
Hydra is an example of an cnidarian that has one of the simplest nervous systems in evolution.
A hydra has between 300 and a few thousand neurons. Remember, we have 86 billion. But the hope is that if we can crack the code of the hydra, we might be able to scale up to, eventually, a human brain. Raphael and his team have mapped the entire brain, which means they can match every time it moves to specific patterns of neurons firing. They're reading its mind. They're reading its mind. But matching patterns is not the same as understanding how they work.
At this point today, we just cannot tell you what these patterns mean. So it's a little bit like listening in on a conversation in a foreign language that you don't understand.
Okay, clearly if we can't understand the brain of a hydra, then we're definitely a long way off from cracking the code of the human brain. But the seductive question underlying it all is this: does the brain fundamentally work like a computer? And if so, can we download our brain onto a computer? Dr. Ken Hayworth definitely thinks so, and he's determined to one day upload his mind to a computer.
At some point, it dawned on me, we are just information could be encoded as ones and zeros.
Ken is mapping tiny pieces of a mouse brain and trying to map something called the connectome, the complex connections of all the neurons.
The connectome in our brain is encoding all of our memories that make us us. And so in the same sense that my computer is really just the ones and zeros on my hard drive, and I don't care what happens as long as those ones and zeros make it to the next computer, it should be the same thing with me. I don't care if my connectome is implemented in this physical body. What I care is if that connectome is implemented in any physical body.
And he's under no illusion of the mammoth task he's taken on.
We are pitifully far away from mapping a human connectome.
But since the technology isn't there right now, he's exploring other ways to wait until it catches up.
Let's find some way to just stop time.
This biomedical company devises new preservation methods for entire organs.
All right.
But Ken doesn't just want to freeze the brain, he wants to preserve all the information within it.
The preserved brain at this level should store all of those memories, all of those personality traits for thousands of years in storage that could allow imaging technologies of the future to read off the connectome and potentially simulate it.
While this technology does preserve the connections between neurons, does it trap the memories inside it? That bit is unknown, but what is known is that most more conventional scientists completely reject the idea that the mind works like a computer at all, making it impossible to upload.
It's too stupid. It simply cannot be done. A waste of time, a waste of money, and it's a waste of our humanity.
Brutal. Here's a more poetic take.
The best analogy I have for the brain is that the brain is like an orchestra that every time it composes, plays a tune, the tune itself changes the instruments of the orchestra. The way complexity emerges from, the biological matter that forms our brains is very different from what you get from pieces of electronics.
We may never be able to fully recreate the human brain inside a computer, or even be able to completely understand its mind-boggling complexity. But until neuroscientists definitively rule it out, people like Ken are gonna keep on trying.